So, good morning dear students, welcome back to my spectroscopy class. Let me continue the ESR spectroscopy. Okay, last class I think that I have discussed about the separation of the electronic spin energy level. Okay, that is what happened to the electronic spin energy level. That is, unless otherwise, the degenerate electronic spin state, that is plus or minus half GE beta B0, is splitted into two electronic spin level under the influence of an applied magnetic field when the paramagnetic molecular species is kept in an applied magnetic field. So you have to think about that. So we have a degenerate spin level of the unpaired electron in a paramagnetic species, that is plus or minus half G beta, okay, G beta into B0, okay. That means we have plus or minus, that is, okay, that is under the influence of an applied magnetic field. This plus or minus spin of moment is broken into or split into two energy levels, okay. Spin energy level corresponding to this ms value, corresponding to this ms is equal to plus or minus of the spin state is otherwise degenerates. In the absence of the applied magnetic field is now split into two components. One is of lower energy, okay. And you know that we have an energy of interaction that is causing the splitting. That one is of half minus half into Ga beta into B0, and other is of higher energy, that is plus half G beta into B0 under the influence of an applied magnetic field B0, where beta is called a Bohr magneton, G is the nuclear electronic G factor. For a field that is given the value as 2.0023, something like that. And this is spacing. This is the spacing between the spin, electronic spin level. So when a paramagnetic molecular species is kept in an applied magnetic field, the magnetic momentum of the electronic spin corresponding to the spin coordinate number ms is equal to plus half or minus half is now split into two component energy levels or into two energy level under the influence of or under the interaction with the applied magnetic field. That is, it is split into two energy levels, that is a lower energy level with a minus half G beta and B0 and a higher electronic spin level with a plus half G beta and B0 with a spacing delta G. Delta is equal to GE beta B0. Last class. So the electronic spin level of a paramagnetic species is separated by a distance of delta I G E beta B0 under the influence of a magnetic field, and the extent of the splitting, okay, this is a thing, this is B0, B is equal to B0 is equal to 0, okay, this is B0. So the extent of the splitting now is directly proportional to. The extent of the splitting is now directly proportional to. Okay. The extent of the splitting, delta E is now proportional to G beta B0. The extent of the splitting is proportional. G and beta are constant, therefore the extent of the splitting is directly proportional to B0. Okay, applied magnetic field. This beta is equal to B0 to 0, plus or minus half. So this is situation of a paramagnetic molecular species under the influence of the magnetic field. The degenerate spin state now split into two different spin energy levels separated by a energy separation delta is equal to G beta B0. With the lower energy level minus minus half G beta into B0, while upper plus half into G beta into B0. This slightly different from the nuclear spin level. In the nuclear spin level, the plus half state is lower energy while the minus half is higher energy. In the electronic spin level, the minus half is of lower energy and plus half is of the higher energy. That is the only difference you have to note here. Normally, the molecule are in the lower electronic spin level. So, when we apply an appropriate electromagnetic radiation to the molecular system, when you apply expose the molecular system to an appropriate electromagnetic radiation or suitable energy, it will absorb the energy from the radiation due to the magnetic dipole interaction. Here the interaction is between the magnetic field of the electromagnetic radiation with the magnetic field of the magnetic dipole, spinning magnetic dipole of the unpaired electron present in the molecular species. I already mentioned the unpaired electron spinning around an axis create a magnetic moment which behaves like a magnetic dipole, and it will create a magnetic field. Okay, this magnetic field, through this magnetic field or this dipole create a magnetic field. The spinning of the unpaired electron behaves like a magnetic dipole which have a suitable frequency. It precedes with the precessional motion as a suitable frequency. So it interacts with the oscillating electric dipole, magnetic dipole of the electromagnetic radiation, and is the precessional frequency of the electron dipole, the precessional frequency of the spinning electron magnetic dipole now become equal to the frequency of the electromagnetic, the frequency of the magnetic dipole of the electromagnetic radiation, and now resonance absorption takes place. That is the principle called ESR. Okay, or you have to remember the interaction is through the magnetic field of the electromagnetic radiation with the magnetic field of the electric dipole created by the unpaired electron. So it is a magnetic dipole interaction as against the general spectroscopy, where it is electric dipole interaction. It is just like NMR. NMR also is a magnetic dipole interaction. So ESR also is a magnetic dipole interaction. Here it is the electron magnet is used. Okay, electron acting as the magnetic dipole. So when you apply suitable frequency radiation, the molecular system in the lower spin level absorb energy from the radiation and get excited to the higher electronic spin level due to the magnetic dipole interaction, or the magnetic field of the dipole interact with the magnetic field of the electromagnetic radiation. And the calculation shows that which electromagnetic radiation is sufficient for the transition. It has shown by calculation that, from the calculation, it has been shown that the microwave radiation possesses suitable frequency to cause the transition of the molecule from lower electronic spin to the higher electronic spin. It was found by calculation. That is, they have the equation, that is, suppose we radiate the system with a radiation, electromagnetic radiation of energy h nu with the frequency nu. Okay, it will absorb the energy from the radiation through magnetic dipole interaction, and tau become equal to delta E. That is equal to GE beta B0. Therefore, nu radiation is equal to GE beta B0 by H. Now, and by calculation, the nu, the frequency of the radiation is found to be, substituting the value of G0, we put the value of G0, which is 2.0023 for a free electron. G, the electron G factor, electron G value is 2.0023 for a free electron, and beta, the Bohr magnetron, is 9.27 into 10 raised to minus 4 joule per Tesla into B0 is applying in the range of 0.3 to 0.4 Tesla. Okay, that is the usual magnetic field that is we are applying. The B0 external magnetic field usually that is a range from 0.3 Tesla to 0.4 Tesla. Supposing it is 0.34 Tesla. So that divided by h 6.625 into 10 raised to minus 34 joule seconds. And calculate is found to be nearly 9.5 gigahertz in the meter. So the frequency of the radiation now found to be for ESR transition is now found to be 9.5 gigahertz. So that is approximately 10 raised to 9 hertz. 10 raised to 9 hertz. This range, the frequency range of 10 raised to 9 hertz comes under the microwave radiation. So, that is electromagnetic radiation of frequency of the order of 10 raised to 9 hertz is suitable for causing or affecting the electronic transition of the molecular species from lower electronic level to the next higher electronic level. And this is usually the microwave radiation. The microwave radiation possesses such a frequency. Okay. So we can affect the electronic transition in any paramagnetic molecular species by irradiating, exposing it with an microwave radiation or radiation in the microwave region, by exposing the molecular system to a magnetic field of 0.3 to 0.4 Tesla. So that is the principle. And therefore it is called, so when we apply microwave radiation of frequency, suitable frequency, then, okay, the molecule undergo transition from the lower electronic state of minus of G0 beta B0 into the higher electronic state of plus of G beta B0. That's electronic spin transition. Okay, it is the spin transition of the electron from lower spin state to the higher electronic spin state occurs that by the absorption of the microwave radiation through the magnetic dipole interaction. Hence it is called a para-electron spin resonance or electron paramagnetic resonance.